Welcome to webinar classes to learn physics. Students, as we know that we are in a lesson laws of motion. So in that till now we studied in that lesson, especially Newton's laws of motion, about inertia, types of inertia, law of conservation of linear momentum, friction, types of friction, and what are the advantages and disadvantages of friction. Today we will learn about angle of friction. See the diagram. There is a block is placed on the table. It is in rest position. Suppose if you apply force on it, there is a friction acting opposite to it. In this diagram, the weight is acting downwards. That is, weight of the block is acting downwards. That means that is mg. W is equal to mg. It is in downwards. At the same time, there is a force exerted perpendicular to the surface from the surface of the table. That force is called normal force, denoted by the letter N. So this is N, and of course this is opposite force, friction force. These two are perpendicular to each other, and this R is known as resultant force. That means R is resolved into two components, N and F. The angle between the normal force to the resultant vector gives the angle of friction. Suppose if you make a parallelogram, that is OBCA, like this, at the same time you can observe there is a triangle CAOR, AOCR, whatever it may be. It is a right angle triangle. From this triangle, you can calculate cos theta. That cos theta is equal to N by R. That is adjacent side by hypotenuse, N by R. Therefore, N is equal to R cos theta. Likewise, sin theta is equal to, this is opposite side, this indicates F by R. That is equal to, Fs is equal to R sin theta. Here Fs is equal to nothing but it indicates static friction, because the block is rest on the surface. Equation 2 by 1, you can have tan theta, that is Fsn by R. But you know the friction is directly proportional to the normal reaction. From that you have Fs by N is equal to mu s. What is mu s? Mu s represents coefficient of static friction. Therefore, tan theta is equal to mu s. From this, we can calculate, we can take the value of theta. Tan inverse is equal to, theta is equal to tan inverse mu s. Theta is equal to tan inverse mu s. So this is the procedure to or the concept to know about the angle of friction. Suppose here you observe that this mg, that is weight, and force you apply, these two are the real forces. Here, this frictional force and normal reaction are the reactionary forces. Okay, that means suppose if you want to calculate tan theta is equal to fs by n, that means suppose it is not the way to calculate the angle of friction. It represents only the concept of angle of friction. But you cannot calculate the angle of friction with this. Here, one thing I want to explain you why you are taking theta bar here, but not here. Why? That means, suppose if you apply the force, the frictional force increases. When the frictional force increases, the resultant vector slope also increases. That means theta also increases. That means angle of friction is directly proportional to the friction. So that is why you consider angle between normal force and the resultant vector. Okay, so this represents only the concept of the angle of friction, but it is not useful to calculate the angle of friction. Hence, to calculate the angle of friction, we have to take another one, that is angle of repose. From this, you can calculate the angle of friction. What is angle of repose? It is the minimum angle of inclined plane at which the body tends to move or ready to move is called angle of repose. Okay. Have a look the diagram. It is an inclined plane. A body is keep on the inclined plane. Now it is just imagine it is rest on the inclined plane. Consider a body of mass m is placed on a rough inclined plane where theta is the angle of friction. In this position, the forces acting on the body are the normal reaction perpendicular to the plane, that's you know. The force of friction F along the plane upwards, that means weight is acting downwards. If you resolve mg into two components, one is mg cos theta and mg sin theta, where mg represents the weight of the body. This mg cos theta is perpendicular to the plane. Here, mg sin theta is parallel to this plane. When the body is at rest, suppose it is not sliding, it is on the rest only. Therefore, you can take the forces, this F is equal to mg sin theta and n is equal to mg cos theta. Okay, these two forces are acting on the same line, which are opposite to each other. Then you can equalize these two forces. F is equal to mg sin theta, n is equal to mg cos theta. Now, if the inclination is gradually increased, this inclination is gradually increased, what happens at a particular value of theta, say alpha, the body will be just ready to slide down. Okay, isn't it? If you increase the angle, this inclination, what happens? The body will be just ready to slide down. Then the angle of inclination is called angle of repose, represented by the letter alpha. Okay. Now, if theta is equal to alpha, what happens? The block will slide down or ready to slide down. Then you can take theta as alpha. So whenever the body is moving on inclination plane, then that friction is called kinetic friction. That is Fk. Here Fk is equal to mg sin alpha and n is equal to mg cos alpha. Isn't it? Here just I took theta as alpha. Why? Because here the block is tends to move or ready to move. From the laws of motion, you can take Fk is directly proportional to normal reaction. So that that kinetic friction is directly proportional is equal to mu k into n, where mu k is the coefficient of kinetic friction. What is Fk? Here already the value is there. Take mg sin alpha and mu k, that is what is an mg cos alpha. So that by cancellation of mg on both sides, you can have mu k is equal to tan alpha. So here alpha is what? Angle of repose. From this you can calculate this angle, that gives the angle of repose. Okay, hope you understand the difference between the angle of friction and angle of repose. So remember, angle of repose is the minimum angle of inclined plane at which the body tends to move or ready to move is called angle of repose. Its value is just mu k is equal to tan alpha. So in this way, you can calculate the angle of repose. Understand? Okay, next. We will go another important topic, that is acceleration of a body sliding down on an inclined plane. Acceleration of a body sliding down on a inclined plane. Suppose if a body is sliding, that is moving from top to bottom. Now we are going to calculate. So what is its acceleration? Of course, you know the acceleration. So whenever the body has velocity, it has an acceleration. Okay. Now take the same diagram. See this diagram. You already know about this diagram. Just try to understand again. Here, there is an inclined plane at which a block is placed on it. Okay, there are the forces acting on it. Here, you know that mg is the weight of the body. Now we'll explain. Consider a block of mass m, is m, is placed on a rough inclined plane of inclination theta. Consider a block of mass m is placed on a rough inclined plane of inclination theta. The forces acting on body are weight mg acting vertically downwards and normal reaction acting perpendicular to the surface. Here the two forces are acting. So one is weight is acting downwards and normal force always perpendicular to the inclined surface. Here the weight mg can be resolved into two components. This is the weight mg. We can resolve into two components. One is mg cos theta perpendicular to the inclined plane and mg sin theta parallel to the surface. These two are the components of the resultant weight mg. Of course, this explanation you already know in your previous classes. Resolution of vectors. From that resolution of vectors, you can have this type of equations. Now, this is mg cos theta perpendicular to the plane and mg sin theta parallel to the plane. From that diagram, you can have these two forces are acting on the same line opposite to each other, so that you can equalize these two forces. N is equal to mg cos theta, F is equal to mg sin theta, right? Now, if the angle of inclination is slowly increased at a particular angle, what happens? The body tends to slide down. That is, when theta is equal to alpha, then the body slide down. Then that alpha is equal to what? Angle of repose. That means when you increase the inclination, so what happened at that up to that time, the body is stationary. So whenever you are increasing the angle of inclination, that means at a particular angle theta is equal to alpha, the body tends to move on the surface of the inclination. So this theta is equal to alpha, that alpha is nothing but angle of repose. Just have a look. If theta is less than alpha, what happens? The body does not slide. If theta is equal to alpha, the body ready to move or the body tends to slide on the surface of the inclination. If theta is greater than alpha, what happens? The body slide down. See, these three things. If less than alpha, it does not slide. It is equal to alpha, it ready to move or tends to slide. If greater than alpha, the body slides down. So when the body is sliding down, then resultant force is given by what happened? It is sliding down. That means this mg sin theta is more than kinetic friction. So that is why you can take F is equal to mg sin theta minus F, that is kinetic friction. So try to understand this equation now. F is equal to mg sin theta minus Fk. Because this mg sin theta is more, so that what happens? The body is ready to move. So mg sin theta minus Fk. But Fk is equal to what? From the equation friction, that is Fk is equal to, this is already known, this equation Fk is equal to mu k into n. Substitute the value of Fk over here, then F is equal to mg sin theta minus mu k n. But you know n value. What is n value from the diagram? N is equal to mg cos theta. Substitute the value of n over here. Therefore, f is equal to mg sin theta minus mu k mg cos theta. So mg as common factor, then we can have sin theta minus mu k cos theta, right? So finally, you got the equation that is resultant force F is equal to mg into sin theta minus mu k cos theta. But you know that if there is a force acting on the body having mass m, it has some acceleration, that is F is equal to ma. That is, of course, you just you already know about from Newton's second law of motion. F is equal to ma. Force is equal to mass into acceleration. Substitute the value of ma in the place of F, then F is equal to ma. Therefore, ma is equal to mj into sin theta minus uk cos theta. So here m and m cancel. You can have only a is equal to g into sin theta minus uk cos theta. You know about the terms. What is a acceleration? What is the acceleration due to gravity? Of course, sin theta, you know, theta value, angle of friction, and mu k is the coefficient of kinetic friction. So when theta, of course, you know, so by knowing all the values, you can easily calculate the acceleration. So this is the expression for acceleration of a body sliding down on rough inclined plane. Understand? So when the body is sliding down from top to bottom, that is here it is at the rest position. When it is coming to the bottom, its velocity changes. Whenever the velocity changes, it has an acceleration. So that acceleration you can easily calculate by this equation. A is equal to g into sin theta minus uk cos theta. Okay, students, I think, hope you understand about the expression of this statement. Now, we will calculate the time taken by a body to slide down on rough inclined plane. What is the time taken from, that is, a body sliding on the inclined plane? Just we calculate the acceleration of the body. Now, we are interested to calculate what is the time taken by the body to slide down on inclined plane. Take this equation. S is equal to ut plus half at square. Here, what S represents is a length or distance traveled by the body. And what is u? Initial velocity. And t is time. And a is acceleration. So this is the equation of the motion of the body when it is moving with the uniform acceleration. You know this equation, S is equal to ut plus half at square. So just if you want, what is initial velocity of the body? Why? Because it is starting its rest. So that is why u as taken as 0. And what is the length of inclination? Say it is L. What is acceleration? Just to be calculated, that is sin theta, g sin theta minus mu k cos theta. So you know the terms, you know the value of u, you know the S and also A. Substitute the values in above equation, that is S is equal to U2 plus half it square. S as L is equal to U as 0 into T, that is 0 plus half. A means what? G into sin theta minus mu k cos theta, then T square. Therefore, T square is equal to, by cross multiply, you can have 2L by G sin theta minus mu k cos theta. So therefore, T is equal to under root 2L by G sin theta minus mu cos theta. So in this way, you can calculate the time taken by the body to slide down on rough inclined plane. So in this way, you can calculate the acceleration of the body when it is moving here. Acceleration of a body sliding down on inclined plane also. So this all we discussed. Likewise, have a look. So this is the expression for acceleration of a body sliding down on rough inclined plane, that is A is equal to G sin theta minus mu cos theta. Similarly, when the body is sliding down on rough inclined plane, it is also given by T is equal to under root 2L by G sin theta minus mu cos theta. So this is the thing. Remember, these two expressions are very important. So while doing the problems, right? So another important topic is pulling the lawn roller is easier than pushing. Pulling the lawn roller is easier than pushing. So means which one is very easier to work on the lawn roller, whether it is pulling or pushing. So imagine which one is pulling or pushing. Suppose if you are in confusing state, just go through it. Now we'll discuss first pulling. Have a look on the diagram. A roller of mass m is kept on a rough horizontal surface. A roller of mass m is a roller which is having a mass m is kept on a horizontal surface. That means its weight is acting downwards. How much it weighs? W is equal to mg. That means you can say the weight mg is acting vertically downwards. So that means there is a force exerted upwards by the surface. That force is called normal reaction, N. Here normal reaction is perpendicularly acting perpendicular upwards. You know this thing we discussed in our previous topics. Observe. Let F be the pulling force acting on the roller towards right. It is the force acting on the roller towards right. Here this is the force we are applying towards right hand direction. So what happens whenever you apply the force, this is into resolved into two components, that is horizontal component and vertical component. This F represents the resultant force and theta makes the angle. So then therefore from the diagram you can have the horizontal component is F cos theta and the vertical component is F sin theta. Okay. Here F is a force, that is pulling force acting on the roller towards right. This force resolved into two components. One is F cos theta and F sin theta. For easily understanding this thing, have a look this diagram. A man is pulling in the right hand side towards right. The force is like this. Suppose if you resolve this force into two components, F cos theta, that is in horizontal direction, that is horizontal component at which the body moves, and F sin theta, it is vertical component. Okay. So the vertical component F acts upwards, but there is no motion in this direction. There is a motion in horizontal direction, that is towards the horizontal component F cos theta. Hope you understand this one. Again, I am repeating. A roller of mass m is kept on a rough horizontal surface. The weight mg is acting vertically downwards. The normal reaction acts vertically upwards. Let F be the pulling force acting on the roller towards right. Therefore, the force resolved in two components, that is the horizontal component F cos theta moves the body. The vertical component F sin theta acts upwards. That means there is no vertical motion. Okay. Now, total upward force, that is total upward force, is equal to the total downward force. Because these two forces are acting on the same line, then you can equalize these two forces. Means there are two forces acting. One is acting downwards and another one is acting upwards. As you know, the downward force is what? Only mg. This is the downward force, mg. So what is the upward force? There are two forces acting on the same line. One is vertical component force, that is F sin theta, and another one is normal reaction or normal force towards upward direction. That means there are two forces acting on the upward direction. One is N and another one is F sin theta. So that you can take the summation of these two forces, that gives the total upward force. That is N plus F sin theta is equal to mg. N plus F sin theta is equal to mg. Therefore, N is equal to what happened? N is equal to take this F sin theta to the right hand side, that is mg minus F sin theta. So this is the N, normal reaction is equal to mg minus F sin theta. Now we will calculate the frictional force acts towards left. Actually, you are pulling the roller towards right, there is a force, that is frictional force, acts towards left. So what is the frictional force? F is equal to mu n. It's a general equation. F is equal to mu n. F is frictional force is directly proportional to the normal reaction. Therefore, F is equal to mu n, where mu is what? Coefficient of friction. Therefore, F is equal to mu n. Take the value of n over here. That n value you already calculated. That is n is equal to mg minus f sin theta. Just you substitute the value of n over here. F is equal to mu into mg minus f sin theta. This is the frictional force acts towards left. So this frictional force acting while you are pulling the lawn roller. Remember what it represents? It is the frictional force acting on the lawn roller when you are pulling it. Okay. This is about the pulling. Now we're going to learn about the pushing. Here we are pushing. See, a lawn roller of mass m is kept on a rough horizontal surface, as you know it. The weight the weight mg is acting vertically downwards. This is mg which is acting downwards. The normal reaction acts upwards. This is the normal reaction acting upwards. Let F be the external force acting on roller towards right at an angle theta to horizontal. Here it is the F. This is the force acting on roller towards right at an angle theta to the horizontal. Just have a look here. Here the man is pushing. This is the force which he is applying. If you resolve this force into two components, one is F cos theta and another one is F sin theta. Okay. Now, what is the horizontal component? F cos theta. This is the F cos theta for which the body moves in this direction. What is vertical component? F sin theta. That is vertically acting downwards. It's acting downwards. Now, the total upward force is equal to the total downward force. Now we'll calculate the how much the total upward force and how much the total downward force from the diagram. What is the total upward force? That is N, which is it's a normal reaction. Upward force. This is a force acting vertically up because this force exerted by the surface of the surface. You can call it as a normal reaction. N is equal to, here there are two forces acting downwards. One is mg, you already know that acting downwards because it's weight. At the same time, there is a vertical component force, that is F sin theta, also acting downwards. That means there are two forces acting downwards, that is F sin theta and mg. So that the total upward force is nothing but N. The total downward force is equal to F sin theta plus mg. So N is equal to F sin theta plus mg. Now we'll calculate the frictional force towards left. What is the frictional force towards left? As per the equation of the force, F is directly proportional to N. F is equal to mu N. Substitute the value of N here. We have F is equal to mu into F sin theta plus mg. Okay. The total frictional force acting towards left is F is equal to mu N, that is equal to mu into F sin theta plus mg. So comparing these two frictional forces, that is while pushing and while pulling, here you can have while pulling, just to see what is the equation. F is equal to mu into mg minus F sin theta. F is equal to mu into mg minus F sin theta. So when you are pushing, you can have F is equal to mu into F sin theta plus mg. Here the plus quantity is there, there minus is there. That means this value is more. This frictional force is more. That means while you are pushing, the frictional force is more. Clearly, the frictional force acting while pushing is more than frictional force acting while pulling. Thus, pulling is very easier than pushing. Remember. Hope you understand about which one is more, that is pushing or pulling, which one is easier to move, pulling or pushing. From these notations, from these equations, so you can easily understand the pulling the landowner is easier than pushing the landowner. Understand? Just have a look at the diagrams. You can easily understand here the man is pulling. So while he is pulling, there is a frictional force is acting opposite to it. If you calculate that frictional force, you can have this value F is equal to mu into mg minus F sin theta. Similarly, if you calculate here, the man is pushing. So when he is pushing, at the same time, there is a frictional force acting opposite to it. So that if you calculate this force, you can have the this type of equation. F is equal to mu into n, that is F is equal to mu into F sin theta plus mg. So that if you observe these two values, frictional forces, one can easily understand that that frictional force acting while pushing is more than the frictional force acting while pulling. Thus, you can have pulling is easier than pushing, right? So this is the about the thing, that is pulling a landowner is easier than the pushing. So understand. So try to go through the one or two times about this explanation. So students, you can easily understand the final result, why the pulling is easier than the pushing. Okay. So in this way, I think this ends this chapter now. But you have to concentrate. This actually this lesson contains 6 marks. The weightage of this lesson is 6 marks. So there are 2 marks question and 4 marks question is also there. So remember, try to go through the all the things and try to understand the concepts and um, write it well. Okay. Here I want to just recollect the pick up some questions which are very important in this chapter. First one is Newton's second law of motion and derivation of its formula. It is a good question, 4 marks question it is. In IPA point of view, I am saying. And next one is mention the methods used to decrease the friction. What are the methods used to decrease the friction? As you know, the friction, if you want to decrease the friction, you have to apply some lubricants and then the friction decreases. Then in this way, we have to use some methods to decrease the friction. Now, why are shock absorbers are used in motorcycles and cars? We are using shock absorbers in motorcycles and cars. That means, I think it comes in the category of impulse. At the beginning, I explained about the impulse. So impulse is very important thing in this thing. That is, we are using shock absorbers. The impulsive force decreases because of the decrease of impulse force. So then it is very comfort to travel on the 2-wheelers and 4-wheelers, right? So another one is this one. That is why the pulling the land roller is easier than the pushing. So this is these are the 4 marks questions. Just to go through it and study well. Okay. So besides that, there are 2 marks questions also. So you concentrate 2 marks questions. Very simple questions are there. That is the definition statements and their units and everything. Okay. So go through this lesson. So again, I'm telling its weightage for IP point of view, its weightage is 6 marks. Okay. So this is the example of law of conservation of momentum. Again, just I want to repeat it because it's an important topic in the chapter. Law of conservation of momentum, you know that equation, the total momentum before collision is equal to the total momentum after collision. So that you can have the that means the total momentum will always remains constant in a particular isolated system. And at the same time, we should remember that there is no external force acting on it. This is the best example of the uh, law of conservation of momentum. Here, there is a gun, a bullet is inserted it. At the beginning, both are at rest. That is, its initial velocity, the gun initial velocity is 0 and the bullet initial velocity is 0. So when you are firing, what happened? The bullet is comes out from the barrel and the gun is recoil. So that you can have the total momentum before firing is equal to the total momentum after firing. Okay.
Sir, conclude, sir. Time is over.
Okay, right. So this from this m1 v1 is equal to m2 u2 is equal to m1 v1 plus m2 v2. Therefore, finally you can have m1 v1 is equal to minus m2 v2. So that negative sign indicates what momentum of the bullet is opposite to the momentum of the gun. So in this way, you can easily explain the law of conservation of momentum with these examples. At the same time, motion of racket also you can explain. It is the best example of law of conservation of momentum, and also the motion of jet plane. Of course, if a bullet fires into two fragments, that are also the law of conservation of momentum examples. So students, concentrate all these concepts and try to understand. Of course, these concepts are very useful not only for IPE, but also they are very useful for doing problems in MSET and JEE examinations. Okay, thank you.